So I'm Francesco Calogero. I'm a theoretical and mathematical physicist, and I served as the Secretary General of PACO. I will focus specifically on what I consider the nuclear materials of major concern, and these are those that might allow a terroristic sub-state group to manufacture a nuclear explosive device. Now, let me emphasize to begin with, this is a very important question, that a nuclear explosive device is very different from a nuclear weapon. A nuclear weapon should be reliable, so the yield should be rather precisely known in advance, in some cases even variable, can be adjusted in advance. A nuclear weapon should be safe, and most importantly, a nuclear weapon should be transportable. In fact, it should be mated to a delivery vehicle. None of this applies to a nuclear explosive device, which most likely will not be reliable. It will be not certain in advance what the yield will be. It could be very small yield, or it could be up to Hiroshima type, or even a little more. It will, of course, not be safe. And most importantly, most likely, it will not be transportable. It will be built in a locale, in a rented garage, or in an apartment in the target city. For this reason, it is much easier to manufacture a nuclear explosive device than a nuclear weapon. Not to mention the fact that a nuclear weapon requires a whole system. You must have the weapon, the delivery systems, and so on. It is, in fact, this may come as a surprise to some of you, it is, in fact, very easy to manufacture a nuclear explosive device if the group who wants to manufacture it and explode it has the required basic material. So the barrier, the difficulty to produce a nuclear explosive device is the difficulty to acquire the basic materials, and I will tell you in a moment which they are. From having the basic materials, the rest is easy. Without the basic material, it is of course impossible, and no terrorist group is able to produce the needed nuclear materials. Now, what are the basic materials? There are essentially two: highly enriched or weapons-grade highly enriched uranium or plutonium. And let me say a few words about each of these materials. Well, uranium is a metal is mainly a mixture of two isotopes. Isotopes are atoms whose nuclei have the same number of protons and therefore the same electrical charge, but a different number of neutrons. For simplicity, we can assume uranium to be composed of just two isotopes, uranium-235 and uranium-238. This number refers to the total number of nucleons, protons and neutrons in the nucleus. Natural uranium is 99.3% uranium-238 and 0.7% uranium-235. Uranium-235 is the one that can be made to explode, produce a nuclear explosion. Uranium-238 cannot be made to produce a nuclear explosion. So natural uranium is essentially almost all uranium-238, with only 7 per thousand of the explosive uranium, which is uranium-235. What is called, so in order to be able to extract nuclear energy from uranium, you have to enrich it in the isotope 235, which is the one that can be fissioned and allows to extract energy from the nucleus, either in a controlled fashion to produce electricity or in an explosive fashion to make an explosion. Low enriched uranium is something which has 3–4% of uranium-235. So you go from 0.7% to 3–4%, and low-enriched uranium is the uranium that is mainly used as fuel for nuclear reactors that produce electricity. And highly enriched uranium has something like more than 90% of uranium-235. So only highly enriched uranium is capable to produce nuclear explosions, so this is the sensitive material that is very dangerous if it could fall in the hands of a terrorist group. The process of enriching uranium in the isotope 235 is very complicated, very energy consuming, and as I already said, certainly out of the possibility of any terrorist group. It is instead realizable by any country that really puts its effort into this task. But it's hard. It's not a simple thing to do. State has to invest scientific, technological, and financial effort in this enterprise. I already said that if a subset group has a sufficient quantity of highly enriched uranium, it can produce a nuclear explosion easily. And now, what is the sufficient quantity of highly enriched uranium to produce a nuclear explosion in this elementary way? I would say that 100 kilograms is more than enough. 100 kilograms of highly enriched uranium is more than enough for a terrorist group to produce easily, with high probability, a nuclear explosion of Hiroshima type, with a yield which will be difficult to predict in advance, even for the group. This quantity of 100 kilograms of highly enriched uranium should be compared with the enormous amounts of highly enriched uranium that have been produced and accumulated during the Cold War, and that are still in existence. So, for instance, in Russia, which is the country that has the largest stock of highly enriched uranium, there are order of magnitude 1 million kilograms of highly enriched uranium. So 100 kilograms is enough to make a nuclear explosive device, and 1 million kilograms are still now in Russia. Much has been done to increase the physical security of the existing highly enriched uranium. A great role in this has played the non-nuclear program, and also a certain advance has been made in the elimination of highly enriched uranium. The most important program in this respect goes under the slogan of megaton to megawatts. It's an agreement between the United States and Russia, and it will have eliminated 500,000 kilograms of highly enriched uranium by the end of next year, when this agreement expires. And also much progress is being made to guarantee the security of highly enriched uranium worldwide. There is also an international agreement now that countries are engaged to guarantee the security of such sensitive material. However, in my opinion, much more could have been done, and much more should be done, much more than it is done now. Perhaps one reason is, as said, that the real understanding of this danger, I don't think, has really penetrated into decision-making bodies, parliaments, and so on. Although, of course, a lot of lip service is paid to this, but it will penetrate if it happens. When there will be such an explosion, I hope not, but it might happen. Now, just a very few words about the other material, which is plutonium. Plutonium does not exist in nature. It has a half-life of 40,000 years, so even if it was produced in the early history of the Earth, it has all disappeared, but it is produced in electricity-producing nuclear reactors, and There are also reactors whose main goal is to produce plutonium in the context of the military importance of plutonium. It requires, in order to extract the plutonium from the the spent fuel elements, very delicate technologies must be used because it's very highly radioactive. Although, however, plutonium is chemically different from the other elements, so one can use chemistry, which one cannot use in the case of uranium, because the difference between uranium-235 and 238 is not chemistry, it's only weight physics. Some countries have accumulated very large stocks of plutonium. Of course, the United States and Russia not as large as highly enriched uranium, but still very large, but also some other countries. The foremost countries that has a considerably large stock of plutonium in Japan. Allegedly, or in fact allegedly, I mean, for this program is justified by the prospect of using the plutonium with reactors to produce energy, but this route has not yet been technologically realized, and it is more expensive than simply not reprocessing plutonium to make it available for energy use. Of course, what I said about the need to protect highly enriched uranium applies as well to the production of plutonium. However, and this is the last statement I make, it is much more difficult to manufacture a nuclear explosive device with plutonium than with highly enriched uranium. Much more difficult. For a long time I thought and I wrote that one need not worry at all about plutonium because it was so difficult to produce a nuclear explosive device that one could not expect a terrorist group to be able to do that. To some extent I've changed my mind. Some people have told me something that makes me, to some extent, change my mind. So I think it might be possible, but I think in any case it is much more difficult than with the highly enriched uranium.